Imagine this. We find another Earth, a planet like ours, orbiting a distant star. Blue skies, oceans, maybe even clouds. This isn't science fiction. This is a real possibility. And it's a discovery that would change everything. For centuries, we've looked to the stars and wondered, are we alone? The discovery of a true Earth twin would answer that question in the most profound way. It would tell us that we are not unique, that the conditions for life can exist elsewhere in the vast expanse of the cosmos. Think about it. A planet with continents and oceans, mountains and valleys. A planet with the potential for life as we know it. The implications are staggering. It would reshape our understanding of our place in the universe. Finding another Earth is no longer a dream of science fiction. It's a quest that drives modern astronomy. And with each new discovery, we get closer to answering one of humanity's oldest questions. Are we alone? Space is vast. It's a cold, dark, and unforgiving environment. And it presents us with immense challenges in our search for another Earth. The distances involved are staggering. Even the closest stars are trillions of miles away. Our current technology is simply not up to the task of traveling to another star system within a human lifetime. Conventional rockets would take tens of thousands of years to reach even the nearest stars. We need revolutionary new propulsion systems to overcome these vast distances. Communication is another hurdle. Sending a signal to a planet light years away would take years, even at the speed of light. Imagine trying to hold a conversation with that kind of delay. It makes real-time communication nearly impossible. Despite these challenges, we are developing new technologies and strategies. We are building more powerful telescopes to peer deeper into space. We are exploring new concepts like solar sails and fusion propulsion. The quest for another Earth is pushing the boundaries of human ingenuity. Finding planets around other stars is no easy feat. The vast distances and the faintness of these distant worlds make the task incredibly challenging. It's like trying to spot a firefly next to a spotlight from thousands of miles away. The brightness of the stars often overwhelms the faint light reflected by the planets. But astronomers have become incredibly clever in their search for these distant worlds. They use sophisticated techniques and advanced technology to overcome these challenges. One method is the transit method. This technique involves observing the light from a star and looking for periodic dips in brightness. Imagine a planet passing in front of its star, from our perspective. As the planet transits, it blocks a small portion of the star's light. This transit causes a slight dip in the star's brightness, a telltale sign of a planet's presence. By carefully monitoring these light curves, astronomers can detect even the smallest changes. By carefully measuring these dips, astronomers can infer the size and orbit of the planet. The depth of the dip can tell us the planet's size, while the timing of the dips reveals its orbital period. Another technique is the radial velocity method. This method relies on detecting the gravitational influence of a planet on its host star. Planets exert a gravitational pull on their host stars, causing the star to wobble slightly. This wobble is minuscule but detectable with precise instruments. This wobble creates tiny shifts in the star's light spectrum, which astronomers can detect. These shifts, known as Doppler shifts, indicate the presence of a planet. By analyzing these shifts, they can determine the mass and orbit of the planet. The amplitude of the shifts gives us the planet's mass, while the frequency reveals its orbital period. These techniques have already led to the discovery of thousands of exoplanets, planets orbiting other stars. Each discovery brings us closer to finding a world similar to our own. While most of these are gas giants or uninhabitable worlds, some are showing promising signs of being Earth-like. These potentially habitable planets lie within the so-called habitable zone, where conditions might be right for liquid water to exist. The search for another Earth continues, with new missions and advanced telescopes on the horizon. Each step brings us closer to answering the age-old question: are we alone in the universe? Section 4. Life as we don't know it. The possibility of alien life. The discovery of an Earth-like planet begs the question: does it harbor life? And if so, what kind of life? Would it be similar to life on Earth, based on carbon and water? Or could it be something entirely different, something beyond our wildest imaginations? The possibilities are endless. Imagine creatures adapted to different gravity, breathing different gases, thriving in environments that would be toxic to us. Life on another planet could take on forms we can barely conceive. Even if we find no signs of intelligent life, the discovery of even microbial life on another planet would be monumental. It would prove that life is not unique to Earth, that the universe is teeming with the potential for life. This knowledge would have profound implications for our understanding of biology, evolution, and our place in the cosmos. It would force us to confront the possibility that we are not alone in the universe. Section 5. To boldly go, the challenges of interstellar travel. Humanity has always been driven by the urge to explore, to push the boundaries of what is known, and venture into the unknown. This spirit of exploration has taken us from the depths of the oceans to the surface of the moon. And now, our eyes are set on the stars. Let's say we find another Earth. Imagine the excitement of discovering a planet that mirrors our own, with vast oceans, lush forests, and a breathable atmosphere. Such a discovery would be monumental, a new frontier for humanity to explore and perhaps even colonize. A planet ripe for exploration, maybe even habitation. The possibilities are endless. New ecosystems to study, new resources to utilize, and perhaps even new forms of life to encounter. But before we can dream of setting foot on this new world, we must first overcome the monumental challenge of getting there. The next question is, how do we get there? The distances involved in interstellar travel are staggering, far beyond anything we have ever attempted. The nearest star system, Alpha Centauri, is over 4 light-years away. This means that even with our fastest spacecraft, it would take tens of thousands of years to reach it. The challenges of interstellar travel are immense, pushing the boundaries of our current technology and understanding of physics. The distances are mind-boggling. We are talking about journeys that span not just years, but potentially centuries or even millennia. This requires a level of technological advancement and resource allocation that is unprecedented in human history. Even traveling at the speed of light, it would take years to reach the nearest stars. And achieving light speed itself is a colossal challenge. According to Einstein's theory of relativity, as an object approaches the speed of light, its mass increases exponentially, requiring more and more energy to continue accelerating. This means we need to develop propulsion systems that can achieve a significant fraction of the speed of light, something that seems impossible with our current understanding of physics. Concepts like nuclear fusion or antimatter propulsion are being explored, but they are still in the realm of theoretical physics and far from practical implementation. Then there's the issue of time dilation. As we approach the speed of light, time itself begins to slow down relative to observers on Earth. This phenomenon, predicted by Einstein's theory of relativity, means that time would pass differently for those on the spacecraft compared to those remaining on Earth. As we approach the speed of light, time itself begins to slow down relative to observers on Earth. A journey of a few years for the travelers could mean decades or even centuries passing on Earth. This creates a paradox where the travelers might return to an Earth that has aged significantly, with all the social, cultural, and personal implications that come with it. A journey of a few years for the travelers could mean decades or even centuries passing on Earth. This raises complex questions about the nature of time, aging, and the very fabric of reality. How would we cope with the psychological and social impacts of such a journey? What would it mean for the families and friends left behind? This raises complex questions about the nature of time, aging, and the very fabric of reality. Scientists and philosophers alike are grappling with these questions, trying to understand the implications of interstellar travel not just from a technological standpoint, but from a human one as well. Despite these challenges, the dream of interstellar travel continues to inspire scientists and engineers. The idea of reaching out to the stars, of becoming a multiplanetary species, is a powerful motivator. It drives innovation and pushes the boundaries of what we believe is possible. We are exploring concepts like generation ships, where multiple generations would live and die on a journey spanning centuries. These massive spacecraft would be self-sustaining, with their own ecosystems and communities, essentially becoming miniature worlds, traveling through the vastness of space. We are researching theoretical possibilities like wormholes, shortcuts through space-time that could connect distant regions of the universe. If such phenomena exist and can be harnessed, they could revolutionize our approach to interstellar travel, making the impossible possible and bringing the stars within our reach. Section 6. The Ethics of Exploration. Our responsibilities to a new world. The discovery of an Earth-like planet would present us with a profound ethical dilemma. This is not just a scientific breakthrough, but a moment that could redefine our understanding of life and our place in the universe. Do we have the right to explore and potentially colonize another world? This question is not merely about the logistics of space travel, but touches on deeper moral and ethical considerations. Or should we observe from afar, respecting the potential for life and the delicate balance of a pristine ecosystem? The untouched beauty of an alien world could hold secrets and wonders beyond our imagination. The history of human exploration on Earth is fraught with examples of exploitation, colonization, and the decimation of indigenous cultures. These historical lessons serve as a stark reminder of the consequences of unchecked ambition and the importance of ethical considerations. We must learn from these mistakes and approach the exploration of another planet with respect, humility, and a deep sense of responsibility. Our actions should be guided by a commitment to preserving the integrity of any new world we encounter. If we find evidence of life, especially intelligent life, our interactions must be guided by principles of non-interference and peaceful coexistence. The discovery of intelligent life would be a monumental event, requiring us to rethink our approach to communication and interaction. We must avoid imposing our values or beliefs on another civilization, and instead seek to understand and learn from them. This mutual exchange of knowledge could lead to unprecedented advancements and a deeper understanding of the universe. The discovery of an Earth-like planet is not just a scientific endeavor. It is an opportunity to expand our horizons and challenge our preconceived notions about life and existence. It's a philosophical and ethical challenge that forces us to confront our own humanity and our place in the grand tapestry of the cosmos. As we stand on the brink of this new frontier, we must ask ourselves what kind of explorers we want to be and what legacy we wish to leave for future generations. As we contemplate the ethical responsibilities of exploring and possibly inhabiting a new world, we are also faced with an equally profound question. What does this mean for our future on Earth? Imagine a moment when humanity stands united, not by borders or conflicts, but by a shared vision of exploration and discovery. A future where the lessons learned from our past guide us towards a more enlightened and sustainable existence. This new chapter in human history could be the catalyst for unprecedented cooperation and innovation, driving us to solve the challenges we face here on our home planet. The exploration of another Earth-like planet isn't just about finding a new home. It's about the possibilities it opens for us to reflect on our relationship with our own world. Could this journey inspire us to take better care of our environment, to cherish the biodiversity that shares our planet, and to strive for a more just and equitable society? As we look to the stars, we must also look within ourselves. The quest for another Earth is a mirror reflecting our hopes, dreams, and aspirations. It challenges us to be better stewards of our planet and more compassionate inhabitants of the cosmos. What do you think? Could Planet X really be our second home? Or are we just scratching the surface of an even bigger mystery? Drop your thoughts in the comments below. And if you enjoyed this video, like, subscribe and press the bell icon for more such content. And if you're fascinated by space exploration and the possibility of life beyond Earth, be sure to check out my other videos. Thanks for watching, and I'll see you next time.